It is day 1 in ALG.2, and today we are beginning Unit 1. I've titled my notes just with Unit 1, and this will be page 1 of our notes. So what you're going to need for your notes today and for our lesson today is this worksheet, or I guess this handout, not worksheet, that I passed to all of you, the factor pairs. And then this is the worksheet. This is the worksheet that will go along with our notes today. So we're going to be doing a lot of this together. I'm going to put that to the side, and we're going to give our unit a title. So Unit 1 is all about systems of equations. Systems of equations. Okay. Now, I'm sure all of you have solved an equation before. Like you're trying to find x, figure out what number you can put for x that makes an equation true. Have any of you solved a system of equations before? Nobody. This is brand new for all of us, right?
And maybe in pre-algebra.
Maybe in pre-algebra? Okay. It could have maybe been something you had a little preview of. Or maybe you've done it and if it's been a while, you don't remember. This will be a refresher. Or if it's brand new for you today, that's great. Coming in with fresh minds. So before we try to actually solve a system of equations, we need to make sure we know how to solve a regular equation. Okay? Sometimes we need to just go back to the basics, make sure we really understand everything. So right here, I'm going to start a little title and just write basics. Basics of solving equations. So first of all, there is a sort of vocabulary word that you're going to probably hear me say quite a bit, and that is like terms. Like terms. Does anybody know what like terms are? Or has anyone ever at least heard that?
Yeah.
Yeah, sound familiar?
Negatives and positives.
Like negatives and positives, maybe? You're in the right direction.
They have the same variable.
Yes. Yes, it's the same variable. Now remember, variables are letters, like x. So like terms are numbers that are attached to the same variables, and they have the same exponents. So that's the other thing. Like terms, numbers with the same variables exponents. So for example, if I have 5x plus 3 plus 2x, what are my like terms?
5x and 2x.
Yes, thank you. 5x and 2x. These are like terms. So whenever I have like terms, as long as they're over here together on the same side of the equal sign, we can combine these. And when I say that we combine them, I just mean we add them together. So 5x plus 2x would give us what? 7x. Good. So those get combined to make 7x. Can I combine 3 with 7x? No, it doesn't have an x, so it's not a like term. I just bring it down, and that's as far as we can go. Now, let me give you another one that you won't see a ton. Well, actually, you will. I'm thinking of geometry. You will see this. How about 3x squared plus 2x minus x squared? Okay, so there's 4 different terms here. 3x squared is a term. 2x is a term. Minus x squared is a term. Plus 4x, that's a term. There's 4 of them. Of these terms I've just written, if I start with my first term, 3x squared, let me underline that. This is my first term. What can I combine with this? What's a like term in this problem?
Negative x squared.
Negative x squared. Good. Now they all have x. Why can't I combine them all?
Some of them are squared.
Yeah, some of them are squared and some of them are not. That's where that second part of the definition comes in. They have the same variables and exponents. This has an exponent of 2. This has no exponent. I cannot put those together. But these both have an exponent of 2, so I can do that. So now I have 3x squared, and then I have a negative x squared. How do I put those together? What's that do?
-1.
It's really like -1. This, if there's no number in front of your x, there's an invisible 1. So it's really like 3 minus 1, which is what? Bless you.
2x squared.
Yes, 2x squared. 3 minus 1 is 2. So 2x squared. Cross those out because I'm done with them. And what else do we have?
2x and 4x.
2x and 4x. Are those like terms?
Yes.
Yes. So we can put them together and what do we get?
6x.
6x. Good. Okay. Y'all got this. That's easy. Okay. Good. So that's important to know because as we are solving equations, you're going to have a lot of like terms and a lot of things that are not like terms. And if you put together just one term that shouldn't be put together, it can mess up the whole problem. So I want to make sure we all know what I'm talking about when I say that, like terms. Okay, so that's one of the first basics of solving equations. We need to know what like terms are. The other thing that we need to make sure we know of are our inverse operations. So I'm going to write that next. Inverse operations. And as I'm writing this, does anybody know what that means? Or again, if you're not sure how to explain it, but you've heard it, tell me, has anybody even just heard this before? Sound familiar? Or maybe it sounds like something you've never heard in your life. Brand new? I bet once I tell you what it is, you'll know. You'll be like, oh, I knew that. Because this is something that you learned about probably way back in pre-algebra. But sometimes that word doesn't get used as much. So first of all, we'll think about inverse. The meaning of inverse is opposite. That's all inverse means. It's opposite. Like when you invert something, you invert the colors on a picture. Now suddenly all the colors are opposite. Or, it's just the opposite. Operations are just the things that we do to numbers, like adding, subtracting, multiplying, dividing. So, underneath here, we're going to write a plus. Right under that plus, I'm going to put a times symbol. And right under that, I'm going to write x, and I'm going to put a little 2 for squared. So this is adding, multiplying, squaring. Adding, like that. Multiply, square. And now I'm going to draw some lines between what will go on the next kind of column across from, or not column, row, the next row across from each symbol we just drew. So if inverse means opposite, what do you think I should put on the opposite side of add?
Subtract.
Subtract, yes, subtract. That's the opposite of adding. Subtracting. How about the opposite of multiply? Division, divide, good. This one I usually don't have somebody that knows the answer for it. What about the opposite? Yeah, really. What about the opposite of square?
Is it square root?
It is! Yes! Square root. Very good. So I'm going to put that X again, and then in red, I'm going to draw my square root. Yes. Square root. Good, good. And these are kind of the main things that we're doing. Every time we're solving the equation, we're either adding something, subtracting something, we're multiplying something, we're dividing something. The last two, square and square root, we don't see those as much until Unit 2. Right now, we're not going to see them a lot at all. But good to keep track of, good to know. And let's see. Something else that is slightly important is, so we just did like terms up here where we could combine them just by adding them together. But what if I have like terms and we're going to combine it with inverse operations? Let me just put a little example here. Example. What if I have 4x minus 2 equals 5 plus 3x. This is an equation now, a basic equation.
Combine like terms.
Uh-huh. Okay, so Holly said, first thing we're going to do is combine like terms. Now, there's an issue, because now we've added a new symbol, an equal sign. That changes things for us. If you have not had me as a teacher recently, something we've started doing, inspired by Diane. If you ever meet Diane, she's one of our students, and she's pretty awesome. We like to draw a line through the middle of our equal sign because, oh my gosh, it makes such a difference in how organized you can make your work. And it really gets rid of some confusion, for me anyway, and for a lot of other students. So we have an equation here. 4x minus 2 equals 5 plus 3x. And then Holly, you said, well, let's combine like terms.
You can subtract the 3x from 4x.
Oh, yeah. Okay, so 3x and 4x, Holly says these are like terms. But now you're telling me to subtract 3x. Why are you subtracting 3x and not adding?
It's on the other side of the equal sign.
Yes. Whenever we combine like terms on the opposite side of the problem, we use the opposite or the inverse operation. Instead of adding, we're going to subtract. We're doing the opposite thing. So good. And 4x minus 3x is
1x.
1x. Do I need to write the 1? Nope, I'm just going to write x. So I have x. And then what?
Bring it down.
Bring everything down. Minus 2 equals 5. Now what would I do?
Add the 2.
Add the
5.
2. Yeah. Add the 2 to both sides, and we get x equals 7. Wonderful. Okay. Now, is there any part of that that doesn't make sense? Because if we feel ready, we can jump into the systems, but I want to make sure that we feel solid about just solving one equation. Was there any part of that that you were like, I mean, I see why you did that, but I wouldn't be able to do that on my own. Does anybody feel that way right now? Or do we feel good?
Good.
Good? Okay. Okay. All right. Talk to me if you don't, because I don't want to leave anybody hanging. How about we do one more for safety? And then we're going to move on to an actual system. Before I move the page, does anybody still need to see this? Or are we ready?
Ready.
Ready. Okay. All right. So, I'm going to title this next page of my notes. Day one notes continue. Do now. So we have done one example together. Let's just do. Ooh, actually, there is one more little thing I want to make sure that we know how to do. I'm going to ask you guys something. If I have an equation like 2x plus 3 equals, let's see, 9. This is a super simple one. If I have this equation, and it really doesn't even matter what equation you have, it could be any numbers, any variables, whatever. The rule of equations is that because there's an equal sign, I can do whatever I want to these numbers as long as I do the same thing on both sides. So, let me ask you this. Just like if I were to start solving this, I would subtract 3 from both sides, right? We're all on board with that.
Mm-hmm.
So I'm doing the same thing to both sides. I'm subtracting 3 from both sides. What if I just did something totally random? What if I did this side times 2 and that side times 2? Can I do that?
Yeah.
Yeah.
Yeah?
You'd still get the same answer either way.
Sure would. So let's see what would happen. How do I multiply 2x plus 3 times 2?
Distribute.
Yes, distribute. We're going to multiply each term like that. So 2 times 2x is good. 4x. 2 times 3 is 6. Bring down equals. 9 times 2 is 18. Good. Okay. Now, to prove that these are the same equation, if we solved both of them, we'd get the same x value. We would. So, let's just see. -6 here. Let's solve them real fast. I'll bring down 4x equals 18 minus 6. What's that, 12?
Mm-hmm.
Okay, 12. Yeah, x is 3. Okay. Then over here, my 2x plus 3 equals 9. Minus 3 minus 3. 2x equals 97.6. Divide by 2, divide by 2. We still get x equals 3. So these are the same equation. We're going to keep this in mind whenever we learn the next technique, that as long as I multiply everything by that number, you can do that. It's going to be the same equation. It's just a, how do I say? It's like equally expanded, but still the same ratio, if that makes sense. So let's actually go to our first system. Let's go to systems. And that was kind of just continuing more of the previous page. I would like to start a whole new page for systems. So I am gonna go to page 3 and retile this. Now we're gonna look up first method. Solving system by, this first method is called elimination. So this is let's look now at that worksheet I gave you. Look at number 1. I have, for number 1, my first problem says negative 3x minus 2y equals negative 6. And then 4x plus 2y equals 4. So the issue here is now we're trying to find x and y. And not only does x and y have to make this first equation true, it has to make the bottom equation true as well. So what you could do is just guess and check. You could try a bunch of x values and see until you get one that works. That would take forever. So we're going to use this elimination method. And what that method is we're essentially just going to add the two equations together, because as long as I'm adding the same thing to both sides, or subtracting the same thing, or multiplying or dividing the same thing from both sides, my equation's not really going to change. It works. I can do that. And I see right here 4x plus 2y, that's a value, equals 4. 4 is a value, so stay with me here. But doesn't that mean that 4 is the same thing as 4x plus 2y because of that equal sign? So if I add 4 to this side and I add 4x plus 2y to this side, I'm technically adding the same thing to both sides, right? Okay, so I'm going to rewrite this problem. And I'm going to show you how we do this. Number 1. Negative 3x 2y equals negative 6. And I have 4x plus 2y equals 4. Okay. So with elimination, we are trying to add both equations together like this to eliminate one of my variables. I either want to eliminate the x's, get rid of them, or eliminate the y's and get rid of them. So if I just start by trying to add all this, I'm going to go up, down. Negative 6 plus 4. What would that give me? Negative 2. Bring down my equal sign. Now, negative 2y plus 2y, what's that? They cancel out. It's 0. 0y. These are eliminated. Now, negative 3x plus 4x, what's that? X. X equals negative 2. Okay, so because we used both equations, that just nearly instantly solved for x in our system. So -2 is going to work as our x value for both of these equations. But the problem is I also need to find y. So if I already have x, I can use that to find y. Here's how we're going to do it. Let's pick either one of these equations. It does not matter which. I'm going to do the bottom one because I like using positive numbers. So I'm going to write also to the side, add equations together to eliminate one variable. And solve for the other. So we solved for x here. Now that we've solved for x, we're going to use this x to find y. And what we'll do is we will plug in the variable we just solved for. Into either of the original equations. But like I said, I'm going to use the bottom equation, so I'm just going to rewrite that. 4x plus 2y equals 4. Just gave you guys a lot to write, so I'm happy to wait a second. A lot of words.
Many times when you multiply a negative and a negative, it becomes positive.
Yes, it would. Are you using the top equation?
Yeah.
Okay, yeah, you will get a positive there. Now using the second equation that I rewrote, what am I going to do whenever I said here, plug in the variable we just solved? What does that mean? What am I doing?
Well, yeah, x.
Yeah.
-2.
Yes, I'm just going to swap out the x right here with -2. Okay, so I'm going to write 4 times, instead of x, -2 plus 2y equals 4. Okay, so I just did that. Now what?
-8 plus 2y.
Yes. Just trace over this.
The answer's 6.
It's 6? Okay, sweet. Let me get up to where you are, and I'm sure you're right. 4 times -2 is -8 plus 2y equals 4.
Plus 8.
Yep, plus 8. Plus
Divide
8.
by 2.
Yes. Break down my 2y equals 8, 9, 10, 11, 12. Divide by 2. And yes, it is 6. You are correct. And that is your system. It's solved. We have our x value. We have our y value. The very, very last step is to write your answer as a coordinate. And a coordinate is just 2 numbers in parentheses with a comma. X comes first, then y. So if it's x, then y, what am I writing in my coordinate?
2. Let's see. -2.
Yes, good. -2, 6. Perfect. And that's it. Not so bad. Do another one. Make sure everybody got time to write all that though. Any part of that number one that didn't make sense? Or do we feel pretty good about it?
Why do we have to put it into a coordinate?
Why do we have to put it into a coordinate? Good question. So we are moving towards the graphs of these equations eventually. So it's more so just forming the habit now, so that later it's not something we have to add on as an extra thing.
Okay.
Now, if I'm going to show you this actually, if I were to put these on a graph, basically what we have here is two straight lines. These are both the equation of a line. And so one of them might look like this, might look like that. And this would be like our system here of equations. The point where they cross is this point that we just found. The intersection. So intersection is the solution. Oh, I can't spell. So if we were to solve these by graphing instead of using this elimination method, however those lines actually look, wherever they cross is that coordinate that we just wrote. Let's look at number 4, actually. And I'm gonna flip my page before I do that, but does anybody still need to see this before I do that? Okay, thank you for telling me. I'll give you a minute here, just let me know when you're ready. Okay, so one more of these, and then we're gonna amp it up a little bit. There's 3 levels to elimination. This is just level 1, where all we have to do is add the equations together and then plug in that answer to find the other variables. So let's just make sure we got that. So this time, I'm gonna do it on my worksheet, save some paper. And I said, let's look at number 4. I'll use a pencil so it doesn't bleed through. So for number 4, my 2 equations are stacked up. What should I do to solve this? Add them together. Okay, so I'll just do that. Add straight up and down. So walk me through it. What am I adding together?
2x and 2x.
Negative 2x and 2x. What does that give me?
0.
0. They cancel. Okay, next.
2x. Check -1. Y.
Yes. 2y, and then you're subtracting a y. So that leaves you with
Why?
y. Okay. Then what?
Bring down the equal sign.
Thank you. Bring down the equal sign. And then
1.
Negative 12 plus 11 is 1.
Ellen.
Are you sure?
Negative.
Thank you. Negative 1. Negative 12 is bigger. If the bigger number is negative, your answer is going to be negative when you're adding. It's okay. It's pretty close. So, y equals negative 1. That was easy. We didn't have to do anything. One just kind of gave itself up. So, now that I know y is negative 1, what should I do?
Plug it in.
Plug it in. Which equation?
The bottom.
Yeah, let's do the bottom one. I'm going to rewrite it. I got 2x minus y equals 11. And so how do I plug that in?
Parentheses.
Parentheses. So that negative 1 goes where y goes. So I'm going to rewrite this problem. Now, let's be careful. This is where I see the most mistakes. Because whenever it says minus something and that something is also a negative number, it's like we just decide to ignore one of those. Those are both important. Include the minus and the negative 1. So we have 2x minus y. Instead of y, we put negative 1. Minus negative 1. Okay? Equals 11. Does everybody understand why I wrote it like that?
So you don't
There's
get
going to be a
confused.
fraction.
Yeah. I don't want to get confused. And also, if I didn't put one of those, it's going to be wrong. You have to include all the symbols. But what happens there? Minus negative
Can
1.
we turn it into a positive?
Yeah. Can I turn into a positive? We can also think of this as negative 1 times negative 1. A negative times a negative makes a positive. So really, this is 2x plus 1, right?
Mm-hmm.
Good. Equals 11. And now what?
Subtract the 1 from 11.
Subtract the 1 from 11. Bring down 2x equals, what is that, 10?
Divide the 2.
Divide by 2.
5.
X is 5. Awesome. Awesome. Okay, so again, just to get us in the habit of writing these as a coordinate, if I wanted to put this answer in coordinate form, what number goes first?
The 5.
5. Good. And then our negative 1. That's it. Circle your answers. In Algebra 2, there is lots and lots of writing taking place. I don't want to have to search all over your paper for it. Make my job a little bit easier. Okay. All right, so we've done 2 together of those. Before we actually jump to the level 2, I want to make sure that each of you has a decent feel of doing these just by yourself without me guiding you. So as a class, we did number 1 and number 4, 2, 3, and 5. You don't have to do all 3 of them, but on this worksheet, I would like for you guys, I'm going to set like a 5-minute timer, not super long. And I want you to just get as far as you can on any of these. And I will give you the answers after that timer goes off. And that way, if any of your answers don't match, we can talk about it. Or if they do, then you can feel good about it. So I'm going to pause our recording and set that timer. Okay, so our timer just went off. And I've got an answer key here. So for number 2, you should have gotten x is negative 2, y is negative 2. For number 3, you should have gotten x is 4, y is 1. And for number 5, you should have gotten x is negative 1, y is negative 4. Okay, so those were the 3 that you guys were doing on your own. I'll leave that up for just a second. Did anybody get all 3 done and correct? Nice. Were there any that maybe you didn't get correct and we'd like to see? Or do we feel good about these? Okay. Well, y'all, if anybody is struggling, don't be afraid to tell me, but I feel like you guys are doing really good. So I think we can move on to the next thing real quick now. Unless I'm wrong, anybody got questions? We feel good? Great, great. Okay. So we have just done elimination level 1. And it's level 1 because it only involves adding the equations together. It takes very little thinking in terms of how do I start this problem. You do the same thing every time. You just add them together, find a variable, plug that variable in. Now, we're going to learn level 2, which actually most people find this the hardest level. Level 3, for some reason, feels easier. I've found in the past, but we'll get to level 3. Level 2, this is where if I were to just add my 2 equations together, the x's are not going to cancel out, the y's are not going to cancel out. So we have to multiply one equation, all right? So let's look at this number 6 here, and I'm going to rewrite it on my note page. I'm going to start on page 4 of my notes. Let's see.
You said we're doing number 6.
Number 6, yes. Page 4. We're going to do number 6. And it's day 1. Notes continue. And this is elimination level 2. Where we multiply one equation. So I have for number 6, it's negative 3x minus y equals 25 and negative x plus 5y equals negative 13. Okay. So, again, if I tried to stack these up, nothing's going to be eliminated. Nothing will cancel. Negative 3x minus x is negative 4x. Negative y plus 5y, that gives us positive 4y. That did nothing for us. This is where this little paper here that says factor pairs, this can be helpful if you're not excellent at mental math, if you don't know your multiplication facts. If you do, this isn't going to be super tricky for you. However, if not, this page helps. So basically what I need to do is think, what could I multiply one whole equation by so that when I do add them together, I do cancel out one of my x's or my y's. So basically I want, if I choose to do x, I need this to be what? What do I need this negative x? Instead of negative x, what would I want to cancel out negative 3x?
Positive.
Yeah, I would want this to be a positive 3x. That way they would cancel. So if I'm just focusing on eliminating the x's, what could I multiply times this negative 1 to make it become 3x?
Negative 3.
Yes, yes. If I multiply this whole equation, the whole thing, both sides, by negative 3, then negative 1x becomes positive 3x, which will cancel there. So I'm going to multiply all parts of my equation. It's like we're doing a big distribution problem. So I have negative 3 times negative x, and we said that is positive 3x. and I'm just gonna bring everything over. Now I have -3 times 5y. What is that?
It's -15.
Yes, -15y. Bring over your equal sign. -3 times -13.
39. Is it 39?
39? I think you're right, yeah. I'm so bad at mental math. Yeah, it's 39. Good. Okay, so I'm done with that part. All we gotta do now is just bring over the other equation. Stack them up and add them. So I had my -3x minus y equals 25. Here, make the x's cancel out by multiplying number that works. Now this is one where you actually don't really need to know your multiplication facts because we had one x and one y for both, -1 and then for both. But this was more so knowing your positive and negative number facts. Which again, if the signs are the same, we get a positive answer. So -3 and -1 give us +3. And we just did that with all parts of our equation. So now that I have multiplied everything, I've distributed that -3 throughout my whole equation. I just rewrote my top equation on top of it. Now it's like we're back to level 1, aren't we?
Mm-hmm.
Let's just add them together. So what's -3x plus 3x?
0.
That's 0. It cancels. -y plus -15y. Almost?
Or negative.
Yes. -16y. Like -1 plus -15, -16 equals 25 plus 39.
64.
64. Okay, and now I have -16y equals 64.
Divide by -16.
Yep, divide by -16. Get y equals y. Very, very close. 4 is right, but it's
-4.
-4. -4. That positive and that negative, different signs give us a negative answer. And this may seem silly, but it is so important because if I get +4 for y and that's not right, when I go to plug it in, I'm going to get the wrong x also. It's going to mess everything up. So be careful with your signs. Be very careful. So I found my y.
You just plug it in, don't you?
Yep, plug it in. Does it matter which equation I plug into? No, it really doesn't. Which one do we want to
Top?
use? Yeah, I would use the top one just because there's no number next to y. Just be careful with that double negative. So we solved for y. Let's plug it back in. -3x minus, instead of y, -4. equals, and be very careful you don't accidentally write part of the other equation. I'm looking at the top one, I'm gonna put 25, not negative 13. Happens more than you think. And now that it's plugged in, if you think you know where to go from here, tell me.
Turn that into a positive.
Yep. Minus negative 4. That is plus 4.
Bring it all down.
Bring it all down. Minus 3x plus 4 equals 25.
Subtract the 4.
Yep. Subtract 4.
Turns it into negative 3x equals 21.
Good. Equals 21.
Divided by negative 3,
Yes.
which equals negative 7.
Yes. Yes. X equals negative 7. Oh, come on. That's so good. So good. So if I were to write this as a coordinate, what would that coordinate be?
Negative 7, comma, negative 4.
Yes, negative 7, comma, negative 4. It is good. This. Right. So let me put a tiny one.
Well, you get a decimal for number 7.
Should not get any decimals on this
At all.
worksheet. What did you get? Let me see. Yes. So, for these, if you So you multiply that whole first equation by 3, and then you can add it.
How do I get it?
Yeah, exactly like straight. Now, if you're right on track, you got it. You got it.
Find a big Saturday, do with the kids, sit down by the side. Buy something, something, down, not two at a time. Smoking cigarettes in the last seat. Trying to hide my sorrow from the people I meet, get along with them. No doubt people say y'all, sing a song for a friend. Change the shape that I'm in. Get back at the start playing again. I'd like to stay with the start over. Flying back down to Texas, I might go somewhere I've never been. I don't have to go home. There used to be the words to this song. Smell of singing again.
You said 7 and 9. Right. For to doing
Which one?
to doing around 7 and 9.
Yes.
I'm just confused.
Let me see.
Okay, sorry. It's
Right. Yeah. Yeah, yeah.
I didn't do it myself, but I have a
Okay, yeah, just figure that
my
Y.
friend is a hairstylist, so
You got it.
if I have any impulses, she does it pretty quickly. Which this was definitely impulsive.
Okay, I see a bunch of people still typing on calculators. Going.
I have a question.
Yeah, go ahead.
So, for number 9, do we have to get like, clear out the X first, or can it be the opposite?
No, I would recommend the Ys. Like, the Ys are gonna be way easier to do, I think. Yeah, I would do the Ys because if you're doing the X's on number 9, you're gonna have to multiply both equations. Because there is no number.
I know that's what I was. Should I get the? Should I
Yeah, I would
cancel out the Y
I would
first?
cancel
on
the
mine?
Ys. Yes.
Okay, that's what I was.
Yes. No, you're right. You're right.
Because I was looking at it, I'm like, there's no way I'm gonna be able to.
You're correct.
So I didn't know if it mattered if we got the Y first or the X
No,
first.
that's a proper question because I think on all of these we may have canceled X's first.
Well, yeah,
So
that's why I wanted to ask before.
yeah,
I just
I'll
started.
make sure to mention that when we unpause the video. Is that valid?
Bless you.
I'm not going to. Keep that going.
Look at the bright light.
30 more seconds and then we'll jump back in. Let's go ahead and start back up. We'll start with number 7. For number 7,